Hello and welcome back again to our channel, Tutoring Made Easy. Please, I'd like to entreat you to watch this video and to let other people around you be aware of this particular video. In this video, we're going to look at algebra trick questions. We're going to solve some questions on algebra and then to learn some tricks that are actually involved. We're going to look at questions on real numbers, fractions, decimals, percentages, and BODMAS or PEMDAS. All right, so we're going to actually start with real numbers, questions on real numbers. One question on, I think, real numbers. All right, and the first question says that we have a set, three sets, set. So you have P, a set P, and it's made up of the numbers 2, square root of 3, and then the number 5. The second set here, which is Q, is made up of the numbers 17, 1 over 6, and then I think square root of 9. The last set, which is set R, is made up of the numbers within an interval -3 less than or equal to x less than or equal to 8, right? And we have been told to determine which of the sets is rational. Which of the sets is rational? Rational. All right. And remember that when we say a set is rational, it means that it contains fractional numbers. So if we say rational numbers, which is represented by Q plus, that is what we mean by rational numbers. We mean which of them are fractions. As I said, that contains fractions. And if we look carefully, we can actually see that set P here do not contain any fractions. Rather, it has this square root of 3, which is actually an irrational number. Remember, we learned that square roots, pi, numbers that are like pi, square roots, and things like that, they're actually irrational numbers. So set P is actually irrational set. It's an irrational number set, right? But if we take set Q, on the other hand, if you take set Q, remember that this square root of 9 is actually what? 3. Why? Because square root of 9 is the same as square root of 3 times 3, which is the same as square root of 3 to the power 1 multiplied by 3 to the power 1. Because the bases are the same and the sign in between them is multiplication, we're going to add their powers or add the exponents. So we're actually having 3 to the power 1 plus 1. And then we have a square root of 3 to the power 2. And remember that the square root sign is actually to the power of half. So you have 3 squared to the power of half. And then this 2 cancels that. And you get 3 to the power of 1. Therefore, we can see that square root of 9 is actually 3. So if it's actually 3, then we know that this number is an integer or counting number, a natural number. Same as the 3. And then 1 over 6 is a fraction. So this set Q contains what? Fractions. This set Q contains fractions. That makes it what? An irrational number set. An irrational. Sorry, I say irrational. That makes it a rational number set. A rational number set. So that makes it rational. So this is a rational set. On the other hand, set R is an interval between -3 and 8. Now, once we make such a statement, and then we also put a condition that where x is such that x belongs to all real numbers. The moment we do that, x belongs to all real numbers, it means that this interval can contain numbers that are actually, rational numbers or irrational numbers. So instead of the simple, solution being, negative, like -3, -2, -1, 0, 1 all the way to let's say 8, instead of this simple solution, we are saying that it can contain fractions. So instead of -3, it can be -3, it can be -2 over 1 over 3, like that, in that order. It can contain fractions. So it can be anything. So this set here, this set R is a set that is neither rational or irrational, because it contains all manner of numbers in there. I hope this particular question is clarified, where you can be able to identify numbers, whether they're actually integers, whether they are whole numbers, whether they are natural numbers, counting numbers, or rational or irrational numbers. All right. So rational numbers are fractions. Irrational numbers are not fractions. So square root of numbers, pi symbol, all of that is irrational, irrational number. Now remember that we started by saying that we're going to solve problems on real numbers, and then the next thing we're going to do is fractions. The next thing we're going to do is we're going to look at fractions. We're going to look at fractions. And to look at fractions, we're going to first look at how to be able to add a fraction. So we're going to look at the question that says a 3 whole number 1 over 2 plus 2 whole number 2 over 3. How do we go about this? If you have a fraction like this, what do you do? I think the first thing to do is to change this mixed fraction. So this is a mixed fraction. A mixed fraction is a fraction that has a whole number and then also has like another fraction attached with it. And that fraction can be proper fraction or an improper fraction. Remember that we said that a proper fraction, if you say proper fraction, the numerator is smaller. So maybe 1 over 8. The numerator is smaller than the denominator. An improper fraction, on the other hand, has the numerator bigger. So you have like 5 over 2. It's an improper fraction. And you have the mixed fraction, which can be an example 3 whole number 1 over 2. That's what we actually do. So the first thing is to change this mixed fraction into an improper fraction. And to be able to do that, we say that we multiply the whole number 3 by the denominator, which is 2. And then when you do that, you add it to the numerator. So 2 here, multiply the 3, add it to the 1. And then when we do that, we divide everything by the denominator, which is 2, because the denominator is what is dividing anyway. All right. So when we do that, we end up getting 6 plus 1 over 2, which is 7 over 2. All right. This is 7 over 2, which is 7 over 2. All right. I hope that helps. That's 7 over 2. So to change that, we're actually having 7 over 2 here, plus, if we do this, 3 times 2 is 6, plus 2 gives us 8 over 3. Bring your equal to sign, don't forget that. And then we can be able to do what we call the addition part of it. Now, there are 2 ways to do that. To do this, 7 over 2 plus 8 over 3, we can multiply this by that. We get 7 times 3. You can also multiply this by that. You get 2 times 8. And then you divide everything by multiplying this by this, which is 2 times 3, like that. All right? And then we end up getting 21. Well, 3 times 7 is 21. 2 times 8 is 16. And then you divide by 3 times 2, which is 6. You end up getting 37. 21 plus 16 is 37 all over 6. 37 all over 6. So that answers our question, or that simplifies the question that we've looked at. The next thing, the next question will be on subtraction. Let's see how we can be able to do some subtraction question and the fractions. How do we do that? So let's take a look at this question here. We have 2 whole number, 1 over 3 minus 1 whole number, 1 over 4. Always bring your equal to sign. We multiply this 3 by 2, we get 6. We add it to the 1, we get 7. We divide it by the denominator 3 minus this 4, multiply this 1, we get 4. Add it to the 1, we get 5. We divide by the denominator. And like I said, there are 2 ways you can do that. In the first example, which was addition, we multiply this by that, which you can do the same thing. You multiply 4 by 7, multiply this by that, and then multiply this by that. So you're going to get 28 minus 3 times 5, which is 15, divided by 3 times 4, which is 12. You end up getting 13 over 12. Okay. The other method, what we're going to do, which is 7 over 3 minus 5 over 4, we look for the LCM, the least common multiple. If you look at the multiples of 3 and the multiples of 4, the lowest in it is 12, actually. It's 12, because it's 3 times 4 gives you 12. Now 3 multiplied by what gives us a 12 is 4. And then with that answer 4, we multiply it by the 7 on top, we get 28. What can we multiply by 4 to get 12? It's 3. We multiply that 3 by 5, and we get what? 15. And then we subtract, we get 13 over 12. So that's the second method, which applies to the addition part as well. I hope this helps. I hope this helps. Now let's take a look at multiplication. Let's take a look at multiplication. All right, look at a question on multiplication. And then the question says, let's look at the question quickly. The question says that, let's say you have 3 whole number, 1 over 7, multiplied by 4 whole number, 1 over 2, multiplied by 1 whole number, 5 over 9. Now this, you multiply 3 by 7, you get 21, plus 1, you get 22 over 7, multiplied by 2 times 4 is 8, add 1 to it, you get 9 over 2, multiplied by 9 times 1 is 1, add to 5, you get 14 over 9. I hope you can convert a mixed fraction into improper fraction. Multiply the denominator by this whole number, get 21, add 1, 22, divided by the denominator, 2 times 4, 8, add 1, 9 over 2. 9 times 1 is 9, add to the 5, 14, divided by the denominator, 9. Now, here we're just going to look for common factors. Common factors. And we can look at this 2 here. Either we deal with this 2 with a 22, or we deal with this 2 with a 14. So it's up to us what we're going to do. I'm going to do 2. We go here 1, and then what we multiply that to get 22 is 11. All right, that's what I'm going to do. Someone will actually start. We'll pick 2 and 14 together. Also, I'll pick 9. 9 goes here 1. 9 goes here 1, like that. So I end up getting 11 over 7 times 1 over 1 times 14 over 1. So we are not done yet. We can also look at the 7. It goes here 1, goes here 2. Or what can we multiply by 7 to get 14, which is 2? And then we end up getting 11 over 1 times 1 over 1 times 2 over 1. We are done. So we multiply the numerators together, which is give you 11 times 1 is 11. 11 times 1 is 11 times 2. We'll give you 22 over 1. And then the answer gives you 22. Okay, I hope that helps. Now let's take a look at division. Let's see how division also works. You can pause the video, go back, pause your video, go back, take a look, review your addition, your subtraction, and then what we've done so far, and then you can continue with a division, how the division also works, how division works. So division of fraction, there's a question here. It says 3 whole number 1 over 4 divided by 2 whole number 1 over 3. 2 whole number 1 over 3. So what are we going to do? How do we go about this? First, we're still going to convert this into what? Improper fraction. 4 times 3 is what? Is 12, plus 1 will be 13 over 4. And then don't forget to multiply 3 by 2, 6, add to 1, you get 7 over 3. And then the next thing we're going to do is that we write 13 over 4. We change the sign to multiplication. The moment we do that, that's also my method. I know there are other methods, out there. You change the division to multiplication. The moment you do that, you're going to reciprocate. That means you're going to turn this thing upside down. So it's going to be 3 over 7. And once we do that, the rest, they say, is, we're going to cancel things out. But if you look at it, there's nothing we can do about what we've done so far. So we're going to multiply the numerators together. We get 39, I believe. And we're going to multiply this again. We're going to get 28. And that gives us our final answer. Now, can someone also be able to convert this? Can you be able to change this into mixed fraction? Yes, we can. 28 actually will go into, what can we multiply by 28 to get 39? If we multiply 2 by 20, that's 56. It's more than this number. So it's actually 1. We can multiply 1 by 28, and then we get 28. And when we take 28 from 39, we're actually going to get 11. So 11 remainder divided by the denominator, which is 28. And to check again, you can multiply this 28 by the 1, we get 28. Add 11 to it, you get 39, divided by 28. I hope this particular, example, works. This particular example works. Now, let's take a look at, we've looked at fractions. We looked at how to add fractions, subtract fractions, multiply fractions, and divide fractions. We've done that. Now, we're going to look at other trick questions on decimals. We're going to look at that. we're going to look at other trick questions on decimals. All right. So how do we change? Let's say you have a fraction. How are you going to convert that into a decimal? How are we going to be able to do that? All right. So, or if you have a percentage, how do you change into into a decimal? So let's say you have 3 whole number 1/2. Sorry, I have to write the title, which is what? Decimals. So we're looking at decimals. And then we're saying that you have 3 whole number 1/2. How do you change this into a decimal? First of all, we change this into an improper fraction, which is going to give us 2 times 3, 6, plus 1 is the same as 7/2. And then now we can go into what? Changing this into a decimal. What do? We go into what we call the long division form. Okay. This is what is doing the division, right? So we're going to have, we have to make a decision of which one is actually going to go in here. All right. Which is whatever is going to go in here. But this time we're going to have our 2 here, I think. Sorry, let me pick a color. We're going to have our 2. Yeah. We're going to have our 2 here because that's what is doing the division. This is the divisor. This is what is dividing 2. And then we also have our 7 inside. All right. So our divisor is outside and our numerator is inside. Now we're going to ask the question, what can we multiply by 2? What can we multiply by 2 to get 7? And the closest is 3. So if we multiply 3 by 2, we get 6. So 3 is what we multiply by 2 to actually get 6. So 3 times 2 is 6. And then we subtract that, we get 1. 1 is the remainder. Now, what can we multiply by 2 to get 1? It's not possible to multiply something by 2 to get 1. And because of that, we're going to introduce what we call a decimal point up here because it's not possible. And then the moment we introduce a decimal point, we add 0 to the 1 here. The moment we put a dot here, add 0 here. Now, what can we multiply by 2 to get 10? And that number is actually 5. That number is actually 5. So that 5 times 2 gives us 10. And then it is finished. Therefore, we can say that, we can conclude that, therefore, we can say that 3 whole number 1/2 is the same as 7/2, and it's actually the same as 3.5, which becomes a decimal, Now, quick facts. Let me make certain statements. Let's say that we have just a normal number, like we have a natural number, a counting number like 2. How can we write 2 as a fraction? If you know the answer, just pause the video and tell me how you can be able to do that. And excellently, is actually 2/1. So any number, whole number, if you divide it by 1, you have represented that number in the form of fraction. If you have 100, in fraction form is 100/1. All right. If you have 25, in fraction form is 25/1. So I hope that helps. I hope you can have that at the back of your mind. And if you want to write a 2 in the context of a decimal, then the 2 is the same as 2.0. The same as 2.0. All right. If you move this 0, you're going to get 20/10 because you moved it once, so it becomes 20/10. And then you cancel. This goes here 1, goes here 2. You end up getting back 2/1 like that. All right. So I hope that clarification actually works. Let's look at percentages. Let's look at percentages quickly. Look at percentages quickly. Let's look at percentages quickly. All right. So let's say the same number, 3 whole number 1/2. How do we convert this into a percentage? Now remember, we said always convert this into a fraction, which gave us 7/2. I know you can do this by now. Now to convert something into percentage, we have to multiply that by 100 all the time. You multiply by 100%. If you want to change something into percentage, multiply by 100%. Now once we do that, we can tell that this is 7/2 times 100%, right? Once we do that, the 2 here, we can write the 100% as over 1, right? And then the 2 here will cancel out to be 1. And then we can multiply 2 by 50 to get 100. So 2 goes into 100, 50. And then we end up getting 7/1 times 50% over 1. Now we can't do anything more. So we're going to multiply this 50 by this 7. And then we end up getting 350. And then we bring the symbol percent there. So therefore, we can say that 3 whole number 1/2 is the same as 350%, like that. The same as 350. percent. So now we've been able to look at how you have a fraction, how you can change what how you can change that fraction into a percentage. We've also looked at how you can change that fraction into a decimal. We've looked at that. Now, how do we also change a percentage back to, maybe you have a percentage? How do you change the fraction? How do you change it to decimal? Let's take a look at that quickly. So let's say that you have a percentage like 25%. Let's say you have a percentage like 25%. 25% is a percentage. How do you write this in a fraction form? Anytime you have a percentage, you divide by 100. Just the same way with a fraction going to percentage, you multiply by 100%. For a percentage, you always divide by 100. So it's 25 divided by 100. So we've converted into what? A fraction here. We've done that. But how are we going to be able to, from here, from the percentage or from this fraction, go into what? Converting into what? Into a decimal. And then the thing we can do here is actually to simplify this first. This will go here 1, it will go here 4. So 25% is the same as 1 over 4, right? The fraction 1 over 25 1. And to change this into a decimal, we're going to do our long division as usual. We said the divisor, this 4, always comes back at the back, because that's what this is doing, the division. And then this one, the numerator, goes inside. Now the question is, what can we multiply by 4? What can we multiply by 4 to get 1? It's not possible. And because it's not possible, we introduce a 0 first. We introduce a 0 first. We introduce a 0. And then once you introduce a 0, that 0 will multiply the 4, and we still get a 0. And then when we subtract, and we get 0 from 1, we still get 1. We still get 1. 0 from 1, from nothing from 1 is still 1. Now the question again is, what can we multiply by this 4 to get this 1? And it is still not possible. So because it's not possible, we introduce a decimal point. And remember, anytime you introduce a decimal point, you have to add 0 to the number here. Now we can ask the question, what can we multiply by 4 to get 10? And the closest we can get is 2. We multiply 2 by 4 and we get 8. We get 8, which is closer to 10. But if you multiply 3 by 4, it's 12. It's more than 10. So it's not prudent. It's not prudent for us to do that. So we put 2 here. So that 2 times 4 gives us 8. And then the remainder is 2. Now the question is, what can we multiply by 4 to get 2? And it's not possible. But this time around, because it's not possible and we've already introduced a decimal point, we're not going to introduce another decimal point. It's not possible. So just add 0 to it and ask the question, what can we multiply by 4 to get 20? And that's 5. So you put 5 here. 5 times 4 is 20. And then you're able to get your final answer. So we know that 25% in fraction terms is actually 1 over 4. In decimal terms, it's actually 0.25. I hope this particular situation helped. Or I hope this problem actually helps. So we've looked at a question on real numbers. We've looked at a question on fraction. We've looked at a question on decimals. We've also looked at a question on percentages. And finally, we're going to look at 2 examples. We're going to look at 2 and stick around. This is the fun part. Don't get tired. Don't get weary. This is the fun part. I'd like you to stick around. Stick around. All right? Stick around. And then we're going to look at, we're finally going to look at board mass. 2 questions on board mass or PEMDAS. I think in the US we call it PEMDAS. In other countries it's called, board mass. I was born and raised in Ghana and, in Africa. And we were taught, board mass. And then when I came to school in the United States, oh la la, I just found out that it's called PEMDAS. But I think that the whole thing here is to do your bracket or your parentheses first, followed by this one is off in an expression. This is rather an exponent in an expression, and this is the division sign. This is a multiplication sign. This is addition sign, and this is a subtraction. So I think the last letter is multiplication, division, addition, and subtraction. It's similar. I think you're going to get the same result. Yes, when you work it out. No matter whichever one you use, you're going to arrive at the same answer, or you're going to get the same results. All right. So, be mindful of which one you want to use. So it's board mass or PEMDAS. Now, the question here we're going to start with is, we have one whole number, 1 over 3 multiplied by 2 whole number, 1 over 4, adding it to 2 whole number, 1 over 2, divided by 5 over 6, like that. Now, always introduce your equal to sign. We are going to change this as usual to what? We change it to mixed fraction. Now, why are we starting that? The rule says we should start with brackets first or parentheses first. So you can either start with this first parenthesis or this second one, whichever way you want to do it. But let's work the ones in the parentheses first. Now, to do that, we still have to change this. We're going to get 3 times 1 is 3. Add it to the numerator 1. We get 4 over 3. Multiply by 4 times 2 is 8. Add it to 1. It gives you 9 over 4. In the parentheses plus, this is going to give us 4 times 4 plus 1 is actually 5 over 2 divided by 5 over 6. So even though you have two parentheses or two brackets here with different symbols in it, here it's multiplication, here it's division. It doesn't matter. You can choose whichever brackets. Why? Because we are supposed to do the brackets first. And since all of them are brackets, you can choose whichever one you want to work with. Whether you pick the one with the division in the brackets or the one with the multiplication in the parentheses, you're still going to arrive at the same answer. So I'm doing the one that is closer to me, which is the left hand side. If I look at that, this goes here 1, it goes here 1. This cancels out. We can multiply 3 by 3 to get 9. And we end up getting 1 over 1 times 3 over 1. We bring addition sign. And then this one gives us 5 over 2. We can also work that at the same time. And then this division sign here, we can change it. We can convert it into what? Multiplication. And once we do that, this goes up and that one also comes down. So it becomes 6 over 5. Like that. And then we can also be able to what? Cancel out, right? We're going to actually right here. We're going to get here 3 over 1 plus into bracket 5 over 2 times 6 over 5. And then we also have to cancel out. Cancel that out. Now this goes here 1, goes here 1. 2 goes here 1, goes to 6 3 times. We end up getting 3 over 1 plus into bracket 1 over 1 times 3 over 1. And then we end up getting 3 over 1 plus another, plus another 3 over 1. Yes, plus another 3 over 1. And then we can do our LCM method, or we can multiply this by that, which gives us 3. Multiply this by that gives us 3. Multiply this by this, you get 1. And we get 6 over 1. 6 over 1 is the same as actually 6. The same as 6. So that's the final answer that we're able to arrive at. You can pause the video and go over it just to make sure that you are grasping the concepts. You are grasping the concepts so far. Now let's take another one that would pretty much cement or clarify certain things for you. Clarify certain things for you. Okay. So let's take 1 over 2 plus 3 over 4 of 2 over 5 divided by one whole number 3 over 5. Let's take something like this. So if we look at this particular problem here, we have addition here, we have off here, we have division here. So if we look at it carefully, if we look bracket first, but there's no bracket here, off is the first, so it means we have to do the off first, which is here. Can you see that? So it is equal to sign half plus 3 over 4 of off means multiplication 2 over 5. So we're going to do that one first, divided by maybe one whole number 3 over 5. All right. So we're going to do the one in the middle first because that's the off one. So we're still going to repeat half plus what? If you look at it carefully, this will go here 1, it will go here 2. So you end up getting 3 over 2 times 1 over 5 divided by 1 whole number 3 over 5. We end up getting 1 over 2 plus this, and this will multiply because there's nothing else to cancel out. We gives us 3, and this one multiplies, and we get 3 over 10 divided by one whole number 3 over 5. Now we're left with addition and division. And if you look at it, PEMDAS, you always do your division before addition. BODMAS, you always do your division before addition. So we're going to look at this side here. Now to do that, let's come up here. Let's come up here and do an equal to sign. We're going to have our half plus 3 over 10 divided by what? We change this. And that one's going to give 5 times 1 gives us 5. Add to 3, get 8 over 5. And then we have half plus 3 over 10. We're going to change it into multiplication. 5 goes up, 8 goes down. And then we try and find out if we can be able to cancel something out. Yes, and 5 go here, goes here 2, and then that's it. So you have half plus 3 over 2 times 1 over 8, right? Which gives you half plus what? 3 over 16. Half plus 3 over 16. And then we can find the LCM, right? You can find the LCM, which is 16. 2 times what will give you 16 is 8. 8 times the 1 is 8. Plus what times 16 will give you 16 is 1. 1 times that 3 is 3. You get 11 over 16 to be your answer. Or you can multiply this by this, you get 16. Multiply this by this, you get your 6. Multiply 2 by 6, you get 32. And then you end up getting, if you look at this one here, right? Two, the 6 plus the 16 will give you 22 over 32. Now, what are we going to do? 2 goes here 11, 2 goes here 16. And then you see that the answer is actually the same. I hope this helps. I'll come to you another time with more algebra trick practice questions. But I'll come to you another time. Take care and bye.